This is another example on the application of triangle law of forces. We have a diagram already given. This is the body P. This dot represents the body P. This is the rope that is attached to the body and tied somewhere here. And the rope is making angle 60 degrees with this vertical line. This is another force P, which is horizontal, that is applied to this same body to pull it to the left side. So that's why the arrow is pointing here. Now, the question is now asking us to find the tension and the force. Do not forget, the force here, the tension here, and the force making two forces. The weight of the body itself is another force. That means let me write the P up here. This is P, this is body P. So the weight always acts downward. That means I can represent the weight of this one here. And that will be 10 Newton. Because we have been given that, okay, if the mass of the body is mass we are given to be 10 kilograms. Sorry, this is 10 kilograms because mass is in kilograms. So we multiply it by 10. Don't forget, weight is equal to mg, and that will be 100 Newton. Okay? So now, how do I turn this into a triangle now? That is the next thing to do. Let's go together. I will make a dot to represent this body. Then let me draw this tension T in the direction. This is the tension T. You can see the same direction. Then this vertical, let me draw it. So the angle between this tension T and the vertical is 60 degrees. But this vertical will now represent this weight. Why? Because this weight is also what? Vertical. As you can see, this and this are parallel to each other. See, if I extend this one up. Since they are parallel to each other, that means this can represent this in this diagram. So this will be what? 100 Newton. The only thing is that the arrow, since the arrow of the direction of the weight is downward, you must put the arrow downward. Then the force F, which is horizontal, that means I can just draw an horizontal line from here. And that will represent this F. The arrow must point left because the arrow is pointing left here. So this is force F here. So as you can see, this one is a right angle triangle because the angle here is 90 degrees. Angle between vertical and horizontal is 90 degrees. So this is a right angle triangle. So if here is 60, here will be 30. But it's not necessary. So the next thing is, how do we solve this? You can use SOHCAHTOA here now. SOHCAHTOA, since it is a right angle triangle. Opposite, hypotenuse, adjacent. Applying SOHCAHTOA, cos 60 will be adjacent over hypotenuse. That's how I make T the subject and got 200 Newton. To find F, F is opposite to 60. That will be opposite over adjacent, which is tan. So making F the subject, that's how F is approximately 173. If you like, you can use this angle 30 degrees because 60 plus 90, that's 150. 150 out of 180, 30. If you use this, you get your answer. Okay?